4 is 9. Diba? So 9 can be written as 3 squared. So then plus, okay, so we have y squared over. So we have 36 divided by 9, that's 4. So 4 can be written as 2 squared. Diba? So then this is equal to 36 divided by 36. So we have 1. Diba? So itatandaan natin na pagdating sa semi-major saka sa semi-minor axis, semi-major axis is always greater than the semi-minor axis. Diba? So kaya dito sa dalawang given na to, so yung dalawang nasa ilalim, diba? So makikita natin na mas mataas yung 3 compared sa 2. Therefore, 3 yung consider natin as semi-minor axis. Yung gagamitin natin as the semi-minor axis. So therefore, A is equal to 3, B is equal to 2. Diba? And makikita natin yung 3 is nasa ilalim ng X, yung 2 is nasa ilalim ng Y. Therefore, yung A is nasa ilalim ng X, B is nasa ilalim ng Y, diba? So that is horizontal ellipse, diba? So, parang nakahiga yung ellipse natin, diba? Pag nasa ilalim ng Y yung A, so then that's a vertical ellipse, no? So although makikita naman natin siya sa sa figure natin later, no? So makikita natin yung form nito is x squared over a squared plus y squared over b squared is equal to 1. Diba? So again, so this is a horizontal ellipse. So horizontal ellipse yan. Okay, so again, pag walang minus h saka minus k, kasi x squared saka y squared lang yan, diba? So then, so this is centered at the origin. So the center is at 0, 0. Okay? So therefore, so kung i-graph natin siya, okay, so we will find something like this. Dito na lang siguro. Okay? So this is the y-axis. No? So then this is the x-axis. Okay? So this is the origin. Okay? So centered at the origin. So start tayo dun. Okay? So we have a center here. Okay? So then, so again, A is 3. And 3 is under x. Diba? So ibig sabihin, so that's along the x-axis. So we have mag-a-add ka ng 3 units horizontally. Diba? So then mag-a-add tayo ng 3 units dun sa kabilang side din. So we have negative 3. So again, from the center. So yun yung ibig sabihin ng A. No? Okay? So again, so yun yung ibig sabihin ng A natin. Diba? So and that's under x. Okay? So yung B naman natin, diba? So is under y. Okay? So kaya that will be above here. Diba? So pataas. So sa vertical naman. So tapos from the center pababa. So another 2 units. So we have negative 2. Okay? So which means, diba? So ito yung magiging ellipse natin. So we will form this ellipse. Okay? Okay ba? So again, so yung ellipse natin is symmetric with respect to x and y axis. No? Okay? So kaya dapat symmetric yung figure natin. Okay? So yan. So meron na tayo ng ellipse, diba? And sabi dito, this is the volume is generated by revolving about the line x is equal to 3, diba? And gaya ng sabi ko sa inyo kanina, so again, x is equal to 3, so vertical line passing through x is equal to 3. Okay? So again, basta x is equal to a constant. Okay? So again, so this is x is equal to 3. So this will serve as our volume of revolution. Okay? So kaya ma-realize natin, diba, may imagine naman natin na makukuha natin na figure. So in this case, diba, is parang donut, diba? So yung itsura. Okay? Like this one. So parang ganito yung magiging itsura ng figure natin. No? Okay? So again, so itong part na to, so you can imagine ito yung parang hole, diba? Butas to sa donut. Okay? Naka ba? So yan. So yan yung figure natin, diba? So pero again, diba? So what we want to do here is, okay, so to get the volume, diba? So of this solid, diba? So and makikita natin since meron yung butas sa gitna, so then, so one way to solve this, diba, is by using the Washer's method, diba? So then the other one is by using cylindrical shells, no? Pero kagaya nung ginawa natin kahapon sa cylindrical shells, okay? So pwede nyo gawin is, pwede nyo i-consider yung buong to, diba? Or pwedeng kalahatiin nyo lang. So since dahil naman sa symmetry ng ellipse, diba? So yung area above the x-axis or yung area above the x-plane, diba? So it's just the same as the volume above the x-plane. So will be the same as the volume below the x plane, diba? Or xz plane to be exact, no? Okay? Naka ba? So pwede nyo gawin yan. So try nyo na lang kung gusto nyo, since naituro ko naman sa inyo kahapon yung paggamit natin ng cylindrical shells. So now, so we will try washer method in this case, no? So tapos later on, Pappus theorem. Okay? So para makita nyo yung iba't ibang method natin sa pag-calculate ng volume of revolution. Okay? So again, so dito, so kukunin natin yung cross-section, di ba? So remember, sabi ko sa inyo kahapon, cross-section natin for the disk methods so is perpendicular to the axis. Ganun din pagdating sa washer method, di ba? So ibig sabihin, ito yung i-consider natin. Okay, so na cross-section. Horizontal, di ba? So kasi vertical yung ating axis of revolution. Okay? So you can imagine na pag kinuha natin yung cross-section nito, so magkakaroon yan ng butas sa gitna. Diba? So we have this hole. Okay? So lagyan lang natin ng konting thickness. Diba? So then, makikita natin na yung thickness natin is along the vertical. Diba? Okay? So kaya alam natin that this is dy. Diba? So yung dh natin, so dun sa washer method equation, is equal to dy. Diba? So as for the radius, diba? So remember, this is 3 units. Diba? Tapos nasaan yung original natin na ellipse, 'di ba? Ito yung original na ellipse, 'di ba? Yung naka-center dun sa origin. Okay, nakaba. So therefore, ito yung magde-define sa atin ng x coordinate saka y coordinate, 'di ba? Okay? So again, so yung magde-define sa atin ng x coordinate saka y coordinate, okay? So now let's define a point, 'di ba? So dun sa ellipse natin. So let's say I define this point. So yung ini-intersect ng hole natin, so dun sa ellipse natin. So then we can define this, diba? So as our x coordinate, diba? So this is the x coordinate. Okay? So and due to symmetry, diba? So of the ellipse, alam natin na pag kinuha natin yung mirror niya, diba? So with respect to the y-axis, remember the y-axis contains the minor axis, diba? So of the ellipse. So meaning yung ellipse natin should be symmetric with respect to the y-axis, diba? So pag minirror natin siya dito, ito yung lalabas na point, 'di ba? So dun sa ellipse natin, makikita natin ito naman yung dulo or yung isang point natin. So dun sa outside circle, 'di ba? So ng disk natin or ng washer natin. Okay? Naka ba? So so yung layo nito, 'di ba? So mula sa y-axis should also be equal to x. So again, so due to symmetry, 'di ba? So in terms of coordinates, alam natin this should be positive and this should be negative, no? But again, so in this case, we are talking about the distance, diba? So, or the absolute distance or the positive distance, diba? So, kaya pwedeng gawin natin parehong positive yung x. So, kaya x na lang yung gawin natin dito pareho, no? Originally, dapat yun ay positive x saka negative x. But again, so we want the distance. So, therefore, okay, so ito, pag ni-negative natin to, so then, yan yung mapupunta dito, diba? So, kaya no need to multiply by -1, okay? Okay ba? So again, absolute distance yung kailangan natin. We need the positive value. Okay? Kaya parehong x lang yung lalabas dyan. So therefore, what are the radius na kailangan natin? So first, the inner radius. Diba? So let me use... okay? So ito na lang. Okay? So again, so for the inner radius, diba? So of the holes, ito yan. Diba? So makikita natin that is the same as this one. So since this is 3 units, tapos ito ay x unit, so alam natin that this should be 3 minus x units. Diba? So then for the outer radius, so ganito yung inner radius natin. Okay? For the outer radius, so that will be from here, diba? So hanggang dito sa axis of revolution natin. Okay? So since this is x units and this is 3 units, diba? So alam natin that this should be 3 plus x units. Diba? So ito naman yung ating outer radius. Diba? So then, so kompleto na natin yung mga kailangan natin for the washer method. So recall from yesterday, dV, diba? So for the washer method is given by pi multiplied by outside radius squared minus inside radius squared multiplied by dh. Okay, so then substituting, okay, so yung mga nakuha natin, so this will be pi multiplied by, so this is 3 plus x quantity squared minus 3 minus x quantity squared, so then dh. Ang dh natin ay dy, di ba? Okay? So then let's simplify first. Okay? So we can expand this using binomial theorem. So you have 9, so plus 6x plus x squared. Then minus, so you will get 9 minus 6x plus x squared. no? So then, this is multiplied by dy. Diba? So then, 9 minus 9 is 0. So kaya magka-cancel to. X squared minus x squared is 0. Kaya magka-cancel din to. Diba? So 6x minus negative 6x is positive 12x. Diba? So then multiplied by pi, so you will get 12 pi. So then x dy. Diba? So this is our differential area. Okay? So then, diba? So area natin, therefore, so will just be the integral. So pag consider natin lahat ng washer dito, so that will cover mula dito sa pinaka-top ng ellipse natin hanggang sa pinaka-bottom ng ellipse. Therefore, from negative 2 to positive 2. So kaya this will be negative 2 to positive 2. Pero again, gaya na sabi ko kanina, so due to symmetry, pwedeng ang kunan nyo lang ng volume dito is mula sa kalahati, diba? So papunta sa pinaka-top. So from 0 to 2, tapos i-multiply nyo lang ng 2. Kasi pareho lang yung volume sa taas at sa baba. No? Okay? So pero ito na lang gamitin natin. So i-factor out ko pala muna yung constant. So which is 12 pi. Okay? So ako nung nag-review ako, sinasanay ko yung sarili ko dati na pina-factor out ko kaagad yung constant. No? So para mabilis siyang ma-solve ng calculator. So minsan kasi bumabagal pag masyadong maraming laman yung integral. So kaya pag pinapasok ko usually sa calculator, dapat naka-simplify na. No? Okay, so now, ang problem na lang natin is, this is in terms of x, but we are integrating with respect to y. Diba? So kaya dapat ilipat natin yung x in terms of y. Remember, x is the x coordinates for the given ellipse. Diba? So therefore, it should satisfy the original equation. So we can use this one, so or yung sinimplify natin na standard form to solve for x. No? Okay? So again, so pwede nyo gamitin, diba? So yung okay, so again, so pwede nyo gamitin dyan yung positive, no? So, square root, pwede nyo rin gamitin yung negative square root. So, although pag negative square root, diba? So, i-multiply nyo pa ng negative 1. So, kaya babalik ka lang din sa positive. Kasi nga, positive distance yung kino-consider natin. Diba? So, therefore, so gamitin na lang natin yung positive square root. So, naman magandang gamitin. So, let me use this one. Okay? So, pag ito yung ginamit natin, solving for x, diba? So, I will leave you with the algebraic manipulation here. So, kaya nyo naman tong i-rearrange, diba? So, ang lalabas dyan ay 36, diba? Okay? So, again, so this is 36 minus 9y squared, no? So, then this is divided by 4. Okay? Makabasa din square root. Diba? Okay? So, therefore, this will be 12 pi. So, then integral from negative 2 to positive 2. Okay? So, then, so this will be x. Yung x natin dito is square root of, okay? So, we have 36 minus 9y squared divided by 4. Okay? So, then this will be dy. Diba? Okay? Okay ba? So, kaya pwede na natin to actually, dv pala to, not dA. Okay? So, dv. So, volume. So, then, so pwede na natin ma-solve dito yung volume. Diba? So, diretso nyo na lang to sa calculator. Diba? So, if you want more simplified version, so then, pwede natin ditong ilabas tong square root of 4. Square root of 4 is 2. 12 divided by 2 is 6. So, pwede nyo gawing 6 pi ito para wala ka ng over square root of 4 dito. No? Okay? So, pwede rin i-factor out yung 9. So, dun sa square root. Diba? So, dito. Pwede nyo i-factor out yung 9. Square root of 9 is 3. So, then you can multiply 3 yung nasa labas. Diba? So, okay. So, para mas simplified. So, although I think kaya na naman ng calculator tong integration na ito. Okay? So, from negative to positive. Okay? So, may matagal siya masasolve ng calculator kasi na merong square root. No? Okay? So this should be 355.3. No? So ito dapat yung lalabas sa solution. So this is letter C. Okay? So yan. So pwede nyo rin i-try sa calculator nyo. No? So kung meron kayong calculator dyan. So again, so para ma-check nyo kung tama yung 355.3. No? Okay? So any questions? No? So again, so another method na pwede natin gawin dito is using Pappos theorem. Okay? Okay ba? So gamitin ko na rin lang tong figure. No? Okay? So for Pappos theorem, so ang kailangan natin i-focus dun is yung area, diba? So na i-revolve natin about an axis. So therefore, in this case, that is the ellipse. Diba? Okay. So burahin ko lang ito. No? So okay, so dito tayo magpo-focus sa ellipse. Diba? So yung una natin kailangan malaman, diba? So is the area, diba? So of the ellipse. So itong area na to. Okay. Okay ba? So yung tatandaan natin for a given ellipse. Diba? Okay. So for a given ellipse, diba? So let's say you are given some ellipse, diba? Okay? So then yung semi-major axis, diba? So will be from the center papunta sa isang vertex ng ellipse, diba? Pag sinabi natin vertex ng ellipse, so yun yung nasa endpoint ng major axis. Major axis is the longer between the two diameters, diba? The longest diameter so of the ellipse, diba? So ibig sabihin, so ito yung major axis natin. So kaya mula dito, so hanggang dito, so ito yung ating semi-major axis, diba? So yun yung dinedenote natin as P. Diba? So then ito naman yung tinatawag nating co-vertex, itong dalawang to. Ito naman yung shortest diameter ng ellipse, that's what we call the minor axis, diba? Kaya mula center so hanggang co-vertex, so that's the semi-minor axis. So yun yung tinatawag nating B. Diba? So and just remember, so that the area of the ellipse, diba, is given by pi AB. Diba? So direct formula yan. Okay? So kaya tandaan nyo lang. Diba? So madali naman siya tandaan. Diba? So in my case, ang tinatandaan ko lang dyan is if A is equal to B, so then tawagin natin as the radius R, diba? So makukuha natin that the area is equal to pi R squared. Okay? Okay ba? So which is area of the circle. So kaya madali lang tandaan kasi pwede mong isipin as pi times R times R. Yung isa dito ay semi-major axis, yung isa dito ay semi-minor axis. Diba? So kaya palitan mo lang yung isang R ng A, palitan mo lang isang R ng B. Diba? Okay? So again, you can prove that using area, diba, of a parametric curve. Mas madaling i-solve yung area ng ellipse pag kinonsider mo siya sa parametric curve. No? So pero madali lang naman tandaan yung formula. So kaya tandaan nyo na lang. No? So again, ano yung A natin? Ito, 3 units. B natin is 2 units. So therefore, okay? So therefore, so yung area na gagamitin natin in this case is pi AB. So this is pi times 3 times 2. So you will get 6 pi. So again, this will be in square units. No? Okay. So lumabas na pala yung sagot sa calculator ko. So 355.3. So tama yung binigay ko sa inyo sagot. No? Okay. So now, diba? So okay na sa atin yung area. So next is the center, no? Okay? So ang tatandaan, centroid, diba? So next, okay? So ang tatandaan natin sa centroid, diba, is one property of a centroid is always located at the axis of symmetry of a given figure, diba? For example, diba, yung sa parabolic segment natin last time, okay? So yung binigay ko sa inyo, diba? So again, is nasa axis of symmetry ng parabola. Diba? So again, somewhere dito yung centroid niya. Okay? So ganun din sa ibang shapes natin, diba? So basta axis of symmetry, alam natin na nandun yung centroid ng figure natin, diba? So kaya pag meron kayong alam na 2 or more axis of symmetry for a given figure, madali nyo hanapin yung centroid. Hanapin nyo lang yung pinaka-intersection nila, diba? Okay? So this time, diba? So dito sa ellipse natin, diba? Nagkataon dito na meron tayong dalawang axis of symmetry, diba? The minor axis and the major axis intersecting at the center. So kaya alam natin yung center natin is the centroid of the ellipse. So balik tayo din sa figure. Okay. Okay? So again, itong center na to, ito yung centroid ng ellipse natin. So kaya para makuha natin yung C-bar, so dun sa Pappos theorem natin, kailangan natin hanapin yung distance nito mula sa axis of revolution. But we know that that is equal to 3 units. Diba? So therefore, alam natin na, okay, So yung C bar natin, diba, is equal to 3 units. No? Okay, so therefore by Pappus theorem, okay, so we will get that the volume, diba, is equal to area multiplied by 2 pi C bar. Okay, so we have 6 pi square units, no? So multiplied by, so we have 2 pi multiplied by, so 3 units. Okay, so then this is equivalent to, okay, so we have 6 pi times 2 pi, so times 3. So we have 355.3 cubic units. Diba? Okay, so kaya again, Pappus theorem is the fastest way usually to solve for solids of revolution. Pero again, so dalawa yung requirement nyo dyan. Diba? So dapat alam nyo yung area saka yung location ng centroid. Diba? So kaya again, so pag may time kayo, so aralin nyo yung mga conic sections natin. Diba? So yun kasi mga madalas na lumalabas. Circle, parabola, ellipse. Diba? Saka mga parts nila. Diba? So sa semi-parabola, semi-ellipse, semicircle, quarter ellipse, saka quarter circle. So syempre may mga lumalabas din na ibang figure. Diba? So minsan may lumalabas sa sinusoid. Okay? So minsan may lumalabas na exponential. Diba? So putol nga lang. Diba? So kasi infinite yung, hindi naman siya loop. Diba? Okay? So kaya minsan pa iba-iba din yung lumalabas na figure. Pero most of the time, conic section yung ma-encounter nyo sa board exam. Diba? Kaya malaking tulong na rin pag memoryado nyo yung mga direct formula. Diba? So yun, syempre, hindi lang naman sa volume of revolution yung magagamit yan. Kasi minsan, tinatanong din mismo yung area. Minsan, tinatanong mismo yung centroid. Kaya kung memoryado nyo yung direct formula, no need for integration. Diba? So yun yung pinaka-advantage nyo. Okay, so let's proceed to the next topic. Diba? So we have a centroid of an area. Okay. So for the centroid of an area, diba? So ang tatandaan nyo lang dito is, okay, so let be the centroid of an area. So be given by G, diba? So such that this will be X bar, Y bar, diba? So then, okay, so yung X bar multiplied by the area, diba? So of the object, okay, so is given by the summation, diba? So this will be the centroid, so X of I, diba? So of parang area, diba? So or smaller area na part ng hinahanapan natin ng area, so multiplied ng area niya, diba? So overall values of I. Okay? Nakaba? So or if we make the area infinitesimal, so or very small, so then we can write this as the integral, diba? So ng x, okay? So tawagin natin to as x sub c, diba? So ito yung centroid ng infinitesimal area natin multiplied by the differential area, diba? So this is overall or over the whole area natin. Okay? Nakuha ba? So for example, diba? So again, so let's say you are given so some figure like this one, diba? So then the idea is we can break this down so into smaller areas, diba? For example, A1, A2, A3, A4. So tapos pag alam natin yung centroids, diba? So nung mga individual areas na nakuha natin, pwede natin gamitin to, diba? Or another option, diba? So is pag hindi natin, wala tayong makuha na common figure, so kung saan makukuha natin yung mga centroids, diba? So then we can make, let's say, small strips, diba? So let's say we have vertical strip, diba? So alam naman natin na pag vertical strip, diba? Sobrang nipis niyan, so kaya yung length lang yung pagbabasehan natin sa centroid. Nandun siya sa pinakagitna, diba? Okay? Nakuha ba? So or we can even use, diba? So yung okay, so double integration. So although pagdating sa centroid, I don't recommend the double integration kasi mas magiging complicated lang equation niya. Diba? So ganito kasi yung double integration. dy dx, diba? Yung centroid niya is yung position niya mismo. Diba? So pero again, so hindi natin dadaanan yung double integration. Diba? So we will use either vertical strip or horizontal strip lang. So horizontal strip, ganun din. Yung centroid niya is nasa pinakagitna. Diba? Kailangan lang natin kunin yung coordinate niya. Diba? So yung x of c. Okay? So similarly, so for y, so y bar times the area is equal to the summation. Diba? So nung smaller areas. Diba? So this is all overall values of I. Okay? So ng y sub I. So again, ito yung ano nila, centroid niya. So times the area. Okay, so for smaller areas, diba? So pwede rin natin gamitin yung integral, diba? So if we use infinitesimal areas, okay? Okay ba? So any questions? Diba? So, para dito. Okay, so yun yung tinatawag natin na centroid. So syempre pag may pag three-dimensional yung pinag-uusapan natin, so dadagdagan nyo lang ito ng z component. Diba? Okay? So although I think wala pa ako nakikitang problem sa board exam na centroid of a volume. As in yung volume na hindi volume of revolution, diba? Yung solid of revolution lumalabas yan sa board. Pero yung solid of revolution kasi madali lang kunin ng centroid kasi alam natin na nasa axis of revolution. Kaya isang dimension lang yung sinasolve natin. Okay? So wala pa ako nakita problem sa board na tatlong dimensions yung isa-solve nyo sa centroid. Okay? So 2 dimensions lang or 3-dimensional na solid of revolution. Okay? Okay? So any questions para dito sa centroid of an area? Okay? So let's try an example. Now, so again, so ito din nakadepende sa problem na kung ano yung gagawin nyo. Pag yung figure natin, diba? So is hindi natin mahati into common figures, diba? So then it's better to use integration, diba? So pero kung kaya naman natin siyang hatiin sa common figures, so we can use yung division, diba? Okay, so i-divide natin siya into common shapes, okay? For example, ang given sa atin is ganito, diba? So ito may lumabas ng ganito dati sa words. No? Okay? Pentagon, diba? Okay, nakuha. So yung pentagon is ni-revolve about this axis. Parang ganyan yung problem, diba? So kaya pag ganitong problem kasi mas maganda gamitan nyo to ng Pappus theorem, no? Mahaba kasi ito pag ginamitan nyo to ng washer method, okay? So or pag ginamitan nyo to ng cylindrical shells. Kasi marami ka ditong lines na involved, diba? So kaya kakailanganin mo ng different division, diba? So ito yung unahin mo. Kasi ito yung lower boundary, upper boundary. So then ito yung pangalawa. So we have lower boundary, upper boundary. So then ito yung pangatlo, lower boundary, upper boundary, diba? So kaya apat, parang hatiin mo pa to sa apat na division, no? So apat na figure bago mo magamitan ng cylindrical shell or this method, diba? Or washer method, no? Okay? It's better to use Pappus theorem. So kaya mas maganda i-solve nyo na lang yung centroid nito, diba? And yung pinakamagandang gawin dito is, diba? So hatiin mo siya sa triangle. So then we have triangle, triangle, saka rectangle. Diba? Okay? So this is the easiest way. Diba? So kaya pwede natin gamitan ng ganito. Okay? Okay ba? So any questions para dito? Okay? So yan. So pero pag yung figure natin again is yung mga curve, diba? So for example, ganitong curve. Okay? So then, hindi natin siya mahati sa alam natin yung location ng centroid sa area. Diba? Okay? Or actually pwede, diba? So pero depende pa dun sa curve natin. Okay? So pero pag ganito, mas madali na itong gamitan ng horizontal strips or vertical strips. No? Okay? So try natin. So example. Okay? Find the coordinates of the centroid of a plane area so bounded by the parabola and the x-axis. No? Okay? So first, okay, so let's start with the parabola. Y is equal to 4 minus x squared. Okay? Standard form. So again, dapat naka-isolate yung x squared. So then this will be equal to negative y minus 4. No? Okay? So this is negative y minus 4. Diba? Okay, so kaya makikita natin na yung format, diba? So nung equation natin is of the form x squared or x minus h squared. So this is equal to, so we have 4a, so times y minus k. No? Okay? So kasi may nakasubtract kay 4. Kaya meron tayong minus, may nakasubtract na 4. Kaya meron tayong minus h saka minus k dito. No? So again, so this is centered. So actually negative to. So kasi negative yan. So this is again, ang vertex nito is nasa hk. Diba? So then yung parabola natin is opening downward. No? So kasi x yung naka-square, so tapos negative yung y. Diba? Okay? So therefore, so dito, so yung vertex natin, so will be located at 0, 4. Okay? So then, so we get the points of intersection ng boundaries natin. Ang boundary natin is ito, saka yung x-axis. So ang x-axis is y is equal to 0. So therefore, so let's solve. At y is 0. So what happens here? So we have 0 is equal to 4 minus x squared. So x squared is equal to 4. So x is equal to plus or minus 2. So therefore, so yung dalawang points of intersection natin, is 2, 0, saka negative 2, 0. Okay? Okay ba? So kaya pag ginraph natin yan, so ganito lang yung shape niya. Okay? So x-axis, y-axis, origin. Okay? So let's say this is 4 units. So this is 2 units. So this is 2 units as well. So negative. Okay? So then we have a point at 0, 4. That's the vertex. Negative 2, 0, saka 2, 0. Okay? So you will get this parabola here. Okay? Okay ba? So again, so for the area, kung gusto nyo i-integrate, so kayo na yung bahala. Pero since alam na naman natin yung direct formula, so gagamitin ko na diretso yung direct formula dito. Diba? So again, so this is 4 units. Okay? So then, this is also 4 units. Okay? So then the area of the parabola is simply 2/3. So times base times height. So parehong 4 units lang yan. So kaya times 4 times 4. So this is 32/3. So actually basta mga parabolic segment na tanong sa board, no? Ang madalas nyo makikita mga sagot dyan ay 16/3, 32/3, 64/3. So something over 3. Okay? So yan yung lumalabas na area natin. So we have 32/3 units. Okay? Okay ba? So any questions so far? Okay? So now that we have the area, diba? So then to solve the centroid, okay? So again, so one way, so is by using, okay, so a vertical or horizontal strip. So pero gamitin na lang natin yung mas madaling gamitin dito. So obviously that is vertical strips, no? Bakit vertical strip? Kasi pag horizontal strip yung ginamit natin dito, so ang boundary natin so will be a parabola and another parabola, diba? So ibig sabihin or half parabola and half parabola. So magkakaroon tayo ng square root. Okay? So kahit hatiin natin yan sa dalawa, for example, ito lang yung consider natin, diba? So again, that's still a half parabola. So and the y-axis. So that will contain square root, diba? And kagaya nung sinusolve natin sa calculator kanina, diba? Pag may square root dun sa integral natin, usually, mabagal siyang isolve ni calculator, diba? So that's why, okay? So ang gagawin natin sa problem na to is vertical strips, no? So it will be easier, diba? Okay? So pero pagdating naman sa board, kahit anong gamitin nyo, okay lang. Okay? So again, so we will use this. No? Yung thickness niya is along the x-axis. Kaya alam natin na dx lang yan. So tapos, diba? So yung height niya, so will be the distance of a point. So dun sa parabola natin from the x-axis, that's the y-coordinate. Diba? So therefore, so we can say that the differential area dA is simply equal to y dx. So ito pwede nyo gamitin to solve the area as well. So pero since alam na natin yung direct formula, mas madali siyang gamitin. No? So saan natin makuha yung y from the given parabola? So kaya we have dA is equal to 4 minus x squared dx. Okay? Okay ba? So meron na tayong differential area. Okay? So ano yung next step natin? So yung centroid, diba? So yung position ng centroid, so nung differential area natin. Okay? So nasaan yung centroid niya? So gaya na sabi ko kanina, nasa pinakagitna lang. Okay? Kung nasa gitna yan, diba? So ibig sabihin, so dito, sa y coordinate, okay? So this is simply y over 2. Diba? Kalahati lang siya ni y. Okay? In terms of the x coordinate naman, diba? Makikita natin na kapareho lang siya ng distance ng point natin so from the y-axis. So that is the x coordinate. Diba? So therefore, in this specific problem, okay? So yung x sub c natin, so for the differential area is equal to x. Yung y sub c naman natin is equal to y over 2. Okay? So which means, diba? So again, so in solving for the centroid, start tayo sa x bar. Okay? So x bar times the area is equal to the integral over the area ng x c dA. Okay? So this will be x bar, so times 32/3. Okay? So then this is equal to, so we have integral. Yung x sub c natin is x. Okay? So yung differential area natin is 4 minus x squared dx. So then this will be evaluated, diba? So sa lahat ng sakop niyang rectangle, so that will be from negative 2 hanggang positive 2. Diba? So negative 2 hanggang positive 2. Okay? Pag sinulog nyo ito, ang lalabas dito, x bar ay 0. No? So one thing is kasi ito, this is an odd function. And pag odd function, pag yung limits of integration natin ay additive inverse, the result is always 0. Diba? So you can check your calculator. No? So pag tinry nyo i-solve yung integral nyo. Okay? Malalabas yun ay 0. Okay? So which just is just another proof, diba? So or another example, diba? So nung sinabi ko sa inyo kanina that the centroid is always located on the axis of symmetry. So dito ang axis of symmetry natin is the y-axis. Again, the y-axis is treated as x is 0, diba? So kaya alam natin ito yung isang centroid or isang coordinate ng centroid natin. Diba? Okay? So about y bar. Okay? So y bar A is equal to integral so ng y sub c dA, diba? So kaya y bar so times 32/3. So this will be equal to integral, diba? So ng y sub c natin is y/2. Okay? So then yung dA natin so is 4 minus x squared. Okay? So dx, diba? So pero yung y, so alam natin na 4 minus x squared lang. So then what we can do here is this 32/3. So we can factor out the 1/2 here. So 1/2. Tapos yung y natin, pareho lang nito. Diba? 4 minus x squared. So ibig sabihin, we can write that as 4 minus x squared dx. So again, this is over the area. Over the area. So yung dx natin, so range from -2 to +2. So this is -2 to +2. So let's solve for y bar. Solve nyo lang yung integral, tapos i-multiply natin ng 3/32. Diba? Okay, so we have integral, so ng 4 minus x squared, so then this is from -2 to +2, okay, so then divided by 2, okay, so times 3 divided by 32. No? Sorry, nawala yung square pala. So, okay, so dapat may square to. Diba? Okay, so kasi yung y na to is 4 minus x squared, diba? Okay, so kaya times another 4 minus x squared. So kaya magiging siyang 4 minus x squared quantity squared. No? So 4 minus x squared squared. So that is from -2 to +2. Okay, so then divided by 2. So then times 3 divided by 32. So you will get 1.6. No? So therefore, so the centroid is located at x bar, y bar. So this is given by, okay, so we have 0, 1.6. No? Okay, so we have letter D. Diba? So, ibig sabihin nandito yung centroid natin. Okay, so somewhere here. Okay, so this is our centroid. Okay? So, syempre, another way is by using direct formula. Diba? Binigay ko na sa inyo last time or kahapon yung direct formula natin for the centroid of a parabolic segment. Diba? So, again, that's 2/5 ng height mula sa base. Diba? So, dun sa figure natin, okay? So, yung base natin so is yung x-axis. Diba? So, kaya basically, so alam natin ito ay 2/5 ng height. Diba? So, which is yung y bar na mismo. Kasi again, so nasa x-axis siya. So, alam natin nasa y-axis yung centroid natin. So, kasi siya ay nasa axis of symmetry. Kaya alam kagad natin na x bar ay 0. Diba? So, therefore, so pag gagamitin natin yung direct formula na yon, so we have x bar is 0. Diba? So, again, this is axis of symmetry. Okay? So, yung pangalawa, diba? So, y bar is 2/5 ng height. Diba? And again, from the figure, ang height natin is 4 units. So, kayo lumalabas na y bar is equal to 1.6. So, makikita natin pareho lang yung makukuha natin sa pag. Diba? Okay, so using the direct formula. So, kaya it's better kung memoryado nyo yung direct formula for the centroid. So, kasi hindi lang naman sa centroid yung magagamit yan. So, even sa solid of revolution. Okay, nakuha ba? Magagamit nyo rin yan sa ibang mga tanong, di ba? Mga center of mass, center of pressure, di ba? So, yung mga fluid force, okay, so etc. etc. Okay? So, any questions so far? Okay. Okay? So, let's proceed to the center of mass. No? Okay? So, yung center of mass naman, diba? So, as the name implies, okay? Para lang siyang centroid, okay? The only difference is instead of dealing with area, we're considering the mass, diba? So, kaya pagdating sa center of mass, nakadepende ito sa problem. Okay? Naka ba? So, meron tayong 3 types na kino-consider pagdating sa center of mass, diba? So, we have linear, diba? So, then yung isa is lamina. Okay? So tapos yung isa naman ay solid, no? Okay? So syempre pag linear, so this is one-dimensional, di ba? Lamina is two-dimensional, so then solid is three-dimensional. Okay? Naka ba? So yun lang yung tatandaan yun. No? Okay? So pag linear, di ba? So syempre, so we have yung tinatawag natin as the linear density, usually denoted by delta. So although huwag kayo malilito sa mga ano nito, sa mga symbols na ginagamit natin kasi minsan nagbabalik-baliktad yan depende sa reference. So sa board exam minsan yung delta nagiging lamina, no? Okay? So yung ginagamit sa lamina na raw minsan nagiging solid. Okay? Tama ba? So kaya ingat lang kayo, no? Kasi nagbabago-bago yan depende sa problem. Okay? Okay ba? So again, so this is the linear density. So yung lamina ay sigma, usually yung ginagamit. So ito yung tinatawag nating surface density, di ba? So ito yung sa area. Okay? So then, so yung solid naman ang ginagamit natin is rho. Di ba? So which is the mass density. Okay? So alam naman natin yung ibig sabihin ng mass density, di ba? Okay? So that is mass per unit volume. Okay? So kaya to solve for the whole the total mass, di ba? Or yung differential mass natin dito dm. So this is simply equal to delta so multiplied by ds. So yung ds natin is yung arc length. Okay, okay ba? So this is the length. Okay? So kaya yan yung kino-consider natin. So kaya if we want to solve for the center of mass, no? So x of m. Okay? So this is simply equal to, so i-multiply lang natin to ng mass. Okay? So then this is equal to, diba? So we have integral, diba? So this is x of c, diba? Or gawin natin tong bar, no? So then this is x of m. So this is the center of mass of the whole line, diba? So pero dito, so this is just the center of mass of the differential area, diba? The differential mass. So this will be dm. Okay, naka ba? So over the whole mass. Kaya again, so para lang siyang centroid, papalitan nyo lang yung area ng mass. Okay, naka ba? So for the y component, so then magiging ganito. So then y sub m, so then we have dm. Okay, naka ba? So pwede nyo rin gawin yung composite na ginawa natin kanina. Yung summation, so ng x sub i, m sub i. So we have x sub i, m sub i, so overall values of i. Okay? So although bihira ako makakita ng ganitong problem pagdating sa center of mass. Sa centroid lang talaga nagagamit ito usually. No? Okay? So and also note na yung centroid natin hindi lang sa area yun. Diba? So meron din tayong centroid of a line, saka meron din tayong centroid of a volume. Diba? So papalitan nyo lang yung area doon. So pag centroid of a line, ang kino-consider natin yung arc length. So yung dA, papalitan nyo ng ds. Yung E, papalitan nyo ng s. Diba? So pag volume naman, papalitan nyo lang yung area ng volume. No? Okay? Sa two-dimensional naman, so then, ang i-consider natin dito area. Diba? So kaya sigma dA. Diba? So tapos ganito na uli yung magiging equation. Okay? So after nito, pag nakuha nyo na to, so then, so yun yung ipapasok nyo ngayon dito. Okay? Saka dito. Okay? Okay ba? So pagdating sa volume, diba? So then yung dm naman natin, so will be rho dv. Okay? Okay ba? So ito naman yung ipapasok natin dun sa dm. Okay? Okay ba? So kaya yan lang yung sa center of mass natin. So yun lang yung difference. Okay? So yan. So pag sinabi nating lamina, ano to? Usually this is a plate, diba? So kaya area lang yung kino-consider natin. So isa siyang, isipin siya parang sobrang nipis na plate, diba? So baga meron tayong certain area, tapos yung thickness niya, so sobrang nipis. Okay? Okay ba? So na hindi na natin kino-consider or hindi na importante yung pagkaka-distribute ng mass natin, so dun sa thickness niya. So mas importante yung sa area. Diba? Okay? So then, so let's try an example. Okay. So now, pag nakakita kayo ng ganitong term, homogeneous lamina, no? So again, ang ibig sabihin nito, so we have a constant density. Okay? So since we are dealing here with a lamina, diba? So isabihin ito yung sigma. So sigma is constant. Okay? Okay ba? So yun yung tatandaan natin pag sinabing homogeneous, diba? So ibig sabihin yan, the mass is uniformly distributed over its entire area. Okay, nakuha ba? So pag nangyari yan, anong mangyayari sa equation natin? Diba? So again, so remember that dm, okay, so is equal to, so this is sigma, so then multiplied by dA. Okay, so therefore solving for the mass, diba? So since sigma is constant, pwede mo siyang ilabas, diba? So this is the integral of dA, so with respect to the whole area. So alam natin na equal lang yan sa area. So therefore this is sigma times the area. Diba? So pag nangyari yan, so then if we use the equation for x sub m bar, diba? So times the mass. So then this is equal to, so again that's an integral, diba? So ng sigma, this will be our x sub m, diba? So then this will be dm, so over the entire mass. Okay, okay ba? So but then, diba? So alam natin na, okay? So yung mass natin, diba? So is just equivalent to sigma times the area. So while yung dm natin, diba? So is equal to sigma, so times dA. So this will be over the entire area, diba? But since yung sigma natin ay constant, so we can factor that out. Okay? So then, so we can write this as sigma, so then integral ng x sub m times dA, so over the entire area. So then magka-cancel to. Diba? So ano mapapansin natin dito? Okay? So yung equation natin, kamukha lang ng equation ng sa centroid. Okay? Nakuha ba? So kaya yan yung kalalabasan. Pag ginawa natin yan sa y-coordinate, ganun din dapat yung lalabas. Kasi pareho lang naman ang composition yung sa x-coordinate saka sa y-coordinate. So therefore, diba? So we can assume that if homogeneous, diba? So yung lamina natin, so this is homogeneous. Okay, nakuha ba? So then yung x sub m bar natin is just equal to x bar. Tapos yung y sub m bar natin is just equal to y bar. Okay, so the center of mass coincides with the center of area, diba? Or the centroid. Okay, nakuha ba? Centroid of an area. Pareho lang sa center of mass. Kaya pag nakakita kayo ng ganyang problem, homogeneous lamina, solve nyo lang yung centroid. Diba? And this is a parabola. This is a linear equation. So we can actually solve this without integration. So unahin natin using integration, then yung kasunod using without integration, no? Or without using integration. Okay, so let's graph first. So let's start with the parabola. Okay, so we have x is equal to y squared plus 1, no? So we can write this as y squared is equal to, so we have x minus 1. So this is x minus 1. So since meron nakasubtract kay x, diba? So ang ibig sabihin, so this is of the form. Okay, so y minus k squared. Okay, so then this is equal to, so we have 4a times x minus h. So positive yung x. Diba? So kaya alam natin this opens to the right. Diba? So opens to the right. Okay, so kasi y yung naka-square, positive yung x. Diba? So opens to the right. Diba? So tapos, ano pa masasabi natin? Vertex is located at HK. Okay? Nakuha ba? So again, so yan yung makukuha natin dyan. Diba? So therefore, so using that concept or that information, so then, so yung vertex natin, so will be located at, yung h natin ay 1, yung k natin ay 0. So this is the vertex, this opens to the right, no? And again, so for the other points of the parabola na concern tayo, so will be yung point of intersection with the linear equation, diba? So i-equate lang natin to sa ito, diba? So we have x is equal to 2y, so that's for the linear equation, and also equal to y squared plus 1 for the parabola, diba? So therefore, rearranging this, you will get y squared minus 2y plus 1 is equal to 0, diba? So which we can factor as y minus 1, okay? Okay, so times y minus 1, so this is equal to 0, diba? So or will give us y is equal to 1. Okay, nakuha ba? So yun yung point of intersection natin. Okay, so again, so we have y is equal to 1. So if y is equal to 1, so by substitution, remember, x is equal to 2y, so kaya 2 times 1 is 2, so x is equal to 2. So therefore, this is one of the points of intersection. Okay? Yung pangalawang concern natin is yung sa y is equal to 0. Diba? So kasi that's another boundary. So at y is equal to 0, substituting do sa parabola natin. So you will get x is equal to 0 squared plus 1. So we have x is equal to 1. So this is 0.10. Okay? Nakuha ba? So tapos, pangatlong concern natin is yung intersection ng line natin sa kanitong line na y is equal to 0. Diba? So then substituting y is equal to 0 dun sa line. So we have x is equal to 2 times 0. So we have x is equal to 0. So this corresponds to the point 0, 0 or the origin. Okay? Nakuha ba? So yun yung mga tatlong points na kailangan natin. So again, para may graph natin na maayos yung figure natin. No? Okay? So again, first, diba? So again, for the parabola, important part, vertex is at 1, 0. Okay? So x-axis, y-axis, 0. So again, yung mga points natin. So we have 1, 0. Okay? So let's say this is 1, 2, 1, 2. No? Okay? So again, first is the vertex of the parabola. That's at 1, 0. That will be this point. Diba? Tapos yung intersection niya with respect to the with respect dun sa line natin, that is the point 21. So that will be this part. Okay? So ibig sabihin, so this will be our parabola. So kalahati lang yung concern natin dito. Okay? So kasi yan lang yung involved dun sa parabola natin. Diba? So again, for the intersection, for the line, diba? So again, aside from this intersection, so yung sa 2, 1, so again, intersection niya with our y is equal to 0, that's actually the x-axis, diba? So it's at the origin, 0, 0. So dumadaan din dito yung line natin. So therefore, so this will be our line. Okay? So this will be our line. Okay? Okay ba? So tapos again, so yung pangatlong boundary natin, y is equal to 0, is passing through 0, 0, and 1, 0. Diba? So kaya again, alam natin yan yung x-axis. So therefore, we are talking about this area here. Diba? So ito yung hinahanapan natin ng centroid. Okay? So again, in this case, yung magandang gamitin. So this, we better use here the horizontal strip. Diba? So rather than the vertical strip. Okay? Bakit horizontal strip this time? Okay? So kasi, okay, so sa vertical strip, makikita natin na pag tinignan natin yung mga vertical lines na to, so again, magkakaroon tayo ng dalawang interval dito. Diba? So kasi dito, sa part na to, sa kaliwa nito, ang boundary natin is the line, so and the x-axis. Diba? So pero dun sa kanan, ang boundary natin is yung line, saka yung parabola. So kaya basically, meron tayong dalawang different boundaries. Diba? So for two intervals. Diba? Kaya hatiin pa natin sa dalawang interval. So kaya para isang integration lang tayo, so then doon na tayo sa horizontal strip. Kasi doon sa horizontal strip natin, kung makikita natin dito sa figure, so ang boundary lang natin lagi is yung line sa kayong parabola. Diba? So isa din yan sa mga consideration natin, syempre, diba? So boundaries. Okay? So let's use, diba? So horizontal rectangular strip like this one. Okay? So makikita natin yung thickness natin dito, diba? So it's along the y-axis, no? In the vertical direction. So that's why this is dy. So then para naman doon sa length niya, so we have this length. So itong length na to, diba? So again, makikita natin na, so again, if we define this, diba? So this is our parabola. So kailangan natin dito is the x component, diba? So kaya from here, pwede natin makuha yung x is equal to y squared plus 1. So we can write it here. So we have x is equal to y squared plus 1. This is our right boundary. Diba? So then for the left boundary naman, so equation itong line. So ang equation ng line natin, so is this one, x is equal to 2y. Diba? So this is x is equal to 2y. So ito naman yung ating left boundary. Diba? So this is just given by, so yung x sa right boundary minus yung x sa left boundary. Okay? Okay ba? So then, since we are solving for the centroid, so we need to locate the centroid of this one. So again, nasa pinakagitna. Okay? In terms of the x-coordinate, diba? So again, pareho lang siya dun sa x-coordinate ng dalawang points natin, or y-coordinate pala, ng points natin. So okay, that is just given by y. Diba? So as for this one, diba? So dun sa x component naman nung centroid nila, makikita natin that this is just the midpoint between the left and right boundaries, diba? So ibig sabihin, this is xl plus xr divided by 2, no? Okay? So again, ano siya? Midpoint, diba? So yun yung equation natin para sa midpoint, diba? Okay? So then, okay? So let's solve, diba? So start tayo sa area. Okay? So para dun sa area natin, okay, so we can solve for dA first, the differential area. Okay? So for the differential area natin, okay, so this is given by, okay, so again, area lang siya ng rectangle na to. So that's base times height lang. So we have xr minus xl. So this is multiplied by dy. Diba? Yung xr natin, so is y squared plus 1. So this is y squared plus 1. Yung xl naman natin is 2y. So we have minus 2y. So then this quantity, dy. Okay? Okay? So again, so yan yung differential area natin. So actually, we can simplify this as y minus 1 squared. Pero kahit hindi nyo naman siya i-simplify, okay lang. No? So kasi solve nyo rin lang naman to sa calculator. So to solve for the area, so ang area natin dito, diba? So will become, so the integral, diba? So of y minus 1 squared. So then this quantity dy. So this is dy. So therefore, it must be evaluated dun sa bottommost part. So that is 0 hanggang dun sa topmost part natin. So remember, this point is 2, 1. So ibig sabihin, this is at 1 unit. Diba? So kaya this will be from 0 to 1. Okay? So then, so what will be our area? Okay? So we have, okay, so integral, diba? So ng y minus 1. Quantity squared. So this is from 0 to 1. Okay? So you will get that this is 1/3. So meron na tayong area. So we have another way to solve for the area. That is by means of direct formula. Diba? Kasi makikita naman natin yung shape niya. So ganito yung shape niya. Diba? So then, so pag in-extend natin to, so then ito, so makikita natin na isa sa mga nagko-compose sa area natin, so is a triangle. Okay? So from the figure, so yung triangle natin has, okay, so from 0 to 2, so yung base niya, so that's 2 units. Yung height niya is from 0 to 1, so this is 1 unit. So right triangle lang to. So we can solve the area. Kailangan lang nating ibawas, diba? So yung parabolic segment natin. Okay? So yung parabolic segment naman natin dito na ibabawas natin, so has a base of 1 unit so and a height of 1 unit. Diba? So 1 unit, tapos 1 unit dito. Okay? So kaya therefore, so another way, okay, so para ma-solve natin to, so will be, okay, so we have 1/2, so times base times height, minus 2/3. Diba? So, okay, so this is times base times height. Diba? So you will get that the area is equal to 1/3. So again, this is without integration. Diba? So kaya rin natin itong isolve without integration. Okay? So any questions para dito? Okay. So then, diba? So let's calculate the centroid kasi yung center of mass natin is pareho lang sa centroid for this problem, diba? So let's start with the x-coordinate of the centroid. So for the x-coordinate, sa akin, ito yung gagamitin natin sa loob ng integral. Okay? Nakuha ba? So then, so again, so equation natin is x bar, so times the area. So is equal to integral over the area, so ng x sub c, so times the differential area. Diba? So again, yung na-solve natin na area is 1/3. So this will be 1/3. So and as for this one, so integral, diba? So ano yung x sub c natin? So again, that's x sub L plus x sub R divided by 2. Okay? So how about our differential area? The differential area is y minus 1 quantity squared dy. Diba? Okay? So this will be y minus 1 quantity squared dy. No? Okay? So again, limits of integration natin. So this is dy, kaya from 0 hanggang 1. No? So this will be from 0 to 1. Okay? So again, ano yung x sub L natin? So x sub L is yung line. Diba? So that is yung 2y. X sub R naman natin is yung y squared plus 1. So kaya this will be 2y plus, okay? So this is y squared plus 1. So divided by 2. Okay? So then this will be times y minus 1 quantity squared dy. So then this is equal to, so again, we can factor out 2, 1 half, no? So integral from 0 to 1. So then, so itong quantity na to, pwede natin siyang i-simplify as y plus 1 quantity squared. Diba? So times y minus 1 quantity squared dy. Diba? So let's try to solve this one. Okay? So we have 1 half, so times integral, diba? So ng y plus 1 squared times y minus 1 squared. So then this is from 0 to 1. Okay? So this is x bar, so times 1/3. So then this will be equal to 4 over 15. Okay? So kaya lalabas dito, x bar natin is equal to 4/5. Okay? Okay ba? So meron na tayong x coordinate. So looking at the choices, isa lang dyan yung merong 4/5 na x bar. Diba? So kaya most likely ito yung tamang sagot. Diba? So pero to check, let's try to solve for y bar. Okay? So y bar times the area is equal to integral over the area. So ng y sub c dA. So yung lalabas dito is y bar times 1/3. So is equal to, so integral. Sa akin, ano yung y sub c natin? Y sub c natin ay simply y. Diba? Okay? So kaya y. Ang dA natin, ito lang. Diba? So that's y minus 1 quantity squared dy. So then, ang limits of integration natin, 0 to 1. So ito kaya-kaya na natin i-solve. So lipat ko yung 3 dito. Multiplied by, so let's try to solve this one. Okay? So integral, so ng y times y minus 1 squared. So this is from 0 to 1. No? So this is 1 over 12. Okay? So ay tama lang. So this is equal to 1/4. So therefore, so yung center of mass natin, tawagin ko as M. So again, this is x sub M, so y sub M. So again, since this is a homogeneous lamina, so this is just equal to the centroid, x bar, y bar. Diba? So again, so this is equivalent to, okay, so we have 4/5, 1/4. Okay? Okay ba? So any questions? Okay. So again, kung ayaw nyo dumaan ng integration, diba? So gamitin lang natin yung ginawa natin kanina to sa figure. Diba? So that is by considering the figure, diba? So to be a triangle minus a parabola. Diba? So pwede mo siyang isipin na, okay, so itong triangle na to, so with a base of 2 units, diba? Height of 1 unit. Okay? Okay? So tapos itong parabolic segment na to, ibabawas natin dun sa triangle. So yung base nito is 1 unit, so yung height nito is 1 unit. Okay? Okay ba? So then, so nakuha na natin yung area, so that's equivalent to 1/3. So we can focus on the smaller areas, no? So again, so let's start with the triangle. Okay? So for the triangle, so this is for triangle. Okay? So the area, okay, so tawagin ko as A1. So this is equivalent to 1/2 times base times height. So then this is equivalent to 1 square unit. Okay? So again, this is A1. Diba? So and para doon sa centroid niya, diba? So remember, nandito yung x sa y axis natin. Diba? So doon sa figure natin kanina. So this is the x-axis, y-axis. So then this is the origin. Okay? So yung tatandaan natin pag right triangle, no? So pag meron tayong right triangle, so yung centroid niya is somewhere here. Diba? Such that, okay, so yung layo nito mula sa base, so ito, okay, so it's 1/3 ng base. Yung layo niya mula dun sa gilid. So again, if this is the base, no? And if this is the height, okay, so yung layo nito mula sa base, so ito, so this is the height divided by 3. Okay? So ibig sabihin, so dito, so yung centroid ng triangle natin will be around here. So such that, diba? So yung layo nito mula dito sa gilid ay 1/3 ng base. Ibig sabihin mula dun sa vertex dito. So this is 2/3 ng base. Diba? So meaning, so yung YC1 natin or yung Y1 natin, Y1 bar, diba? So this will be given by, okay, so this is 2/3 ng 2 units. So this is 2/3 times 2. So that's equivalent to 4/3. Okay? Okay ba? So for the, sorry, X pala to, not Y. Okay? So kasi siya ay layo from the from the y-axis. No? Okay, so tapos yung layo naman ito from the x-axis. So again, that's from the base, kaya ito ay 1/3. Diba? So nung height. Diba? Yung height natin, 1 unit. Diba? So, y1 bar is equal to 1/3 ng 1 unit. So, this is equivalent to 1/3. Okay? So, meron na tayong sa triangle. So, yung next is yung sa parabola. Diba? So, for the parabolic segment, okay? So, then we have yung area. So, tawagin natin as A2. So, again, this is 2/3 times base times the height. Parehong 1 unit. So, then this is equivalent to 2/3 square units. Diba? So, as for naman dun sa centroid niya, diba? So, again, yung direct formula natin, pag half parabola, so kasi half parabola to, kailangan alam lang natin kung nasaan yung base, tapos kung nasaan yung height, diba? So, ang trick lang dyan, hanapin nyo kung nasaan yung vertex, diba? Nasaan yung vertex natin? So, nasa 1, 0. So, nandito yung vertex, diba? So, which means, ito yung vertex natin, okay? So, from the vertex, yung katapat niya, that's the base. So, rin itong nasa gilid, siya yung height, diba? So, therefore, so the centroid is somewhere around here, no? Okay? Okay, so ito. So, tapos yung layo niya from the base, the base is equal to, so this is 2/5 ng height. Okay? So, tapos kung hindi ako nagkakamali, ang layo niya from the height, so yung layo niya naman mula dito, okay? So, this should be 3/8 the base of the base. So, either 3/8 or 3/10, no? So, check muna natin sa 3/8, no? So, parang yan kasi yung naaalala kong value niya. Okay? So, that's 3/8 of the base, diba? So, therefore, okay, so pagdating dun sa, okay, so yung sigurado muna tayo. So, let's start here from the y-axis, diba? So, again, so from the base, that's 2/5 ng height. Ibig sabihin dito siya ay 3/5 ng height, diba? So, kaya ibig sabihin, so dito yung x bar natin, so x2 bar. So, this is 3/5. Ang height natin is, hindi pala mula dyan, sorry. Mula sa vertex lang, no? So, remember that this is 1 unit mula dito hanggang dito. That's 1 unit. Tapos ito ay 3/5 ng height. Okay? Okay ba? So, that's why, or hanggang dito. Let's say nandito yung centroid natin. Okay? So, then this is 3/5 ng height plus 1. So, this will be 3/5 ng 1 unit plus 1 unit. So, this is equal to 8/5. Okay? So, again, so this is equivalent sa 3/8 ng base. Diba? Ito yung base natin also, 1 unit. So, this is equal to 3/8 times 1 unit. So, this is equal to 3/8 unit. Okay? Ako ba? Tapos, remember again na yung buong figure natin, so itong figure na to is just the triangle minus the parabola. Diba? So, therefore, so dito ko na isolve. Okay? So, therefore, so start tayo sa x bar. So, again, x bar times the area is just equal to, so again, x1 bar, so times a1. Since minus parabola na siya, so gagawin lang natin itong minus. So, we have x2 bar, so times a2. Okay? So, again, so x1 bar, so is 4/3, no? Ang area niya is 1 minus x2 bar is 8/5. So, tapos ang area naman nito ay 2/3, no? Tapos again, this is x bar, so times 1/3. So, let's try to solve for x bar here. Okay? So, pag sinolve natin si x bar, so we have 4/3 minus 8/5 times 2/3. So, then that's times 3. Diba? So, you will get this is 4/5. So, as you can see, pareho lang siya nung na-solve natin dito. Diba? So, para sa y bar naman, so y bar area is equal to, so y1 bar a1 minus y2 bar a2. Diba? So, then this is y bar, so times 1/3. So, this is equal to, so ang y1 bar natin ay 1/3. Ang a1 natin ay 1. Diba? Ang y2 bar natin ay 3/8. Okay, so then, ang a2 natin ay 2/3. No? Okay? So then, so this will be 1/3 minus 3/8 times 2/3. So then, times 3, diba? So tama yung equation natin. So we have 1/4. Okay? So this is our equation. Okay? So pag na-encounter niyo naman is yung tinatawag na spandrel, no? Parabolic spandrel. So ito yung nasa kabilang side ng parabolic segment. So ganito yung tinatawag nating spandrel. Para siyang right triangle pero yung hypotenuse niya is parabolic, di ba? That's a parabolic spandrel. Okay? So that is in this case, if this is the base, this is the height. So again, so ito yung vertex, no? So ito yung vertex ng ating parabolic spandrel, di ba? So then yung centroid natin is located here. Okay, nako ba? So tapos, yung layo nito mula sa base, okay, so ito. So this is given by h over 4. Okay, nako ba? So remember sa triangle, h over 3. So pag parabolic spandrel, h over 4. Okay? So tapos yung layo naman niya, so from the height, so ito. So for the centroid, okay? So ito yung 3 over 10. Okay, so times the base. Okay? Okay ba? So any questions para dito? Okay? So pwede nyo rin tandaan yan. Nabasa kung gusto nyo. Okay? So para pag naka-encounter kayo ng spandrel, so direct formula na rin lang. No? Okay? So any questions so far? Okay, okay ba? Sa akin, so yan yung center of mass natin. Okay? So then, next topic tayo. So this time, so moment of inertia naman. So yung pag-aaralan natin. So moment of inertia, para din lang ng centroid or yung ginagamit natin to measure the centroid. So although, instead of x, diba? So instead of degree 1, yung ginagawa natin doon sa coordinates, ang ginagamit natin ay second degree. Diba? Okay? So kaya for moment of inertia, okay? Okay? So for moment of inertia, diba? So ang gagawin lang natin dito is, okay, so yung equation natin dito is the moment of inertia, so the differential moment of inertia. So again, this is for a differential area. So this is given by, so we have r squared multiplied by the differential area. Diba? Tapos i-add lang natin lahat ng differential area so for the whole area. Diba? So ibig sabihin, diba? So if we want to get the moment of inertia with respect to a certain axis, so this will be given by the integral, so ng r squared dA. So this is with respect to the area. Diba? Okay? So ito yung tinatawag din natin as the second moment. Diba? So kasi kung napansin nyo dun sa centroid natin na equation, diba? So basically we have r bar times the area, diba, is equal to, so this is second moment of an area. Okay? So again, so yung r bar times the area is equal to integral, so over the area ng r times a, diba? Ganito yung format nung sa centroid, diba? And makikita natin, RDA, sorry. Okay, so makikita natin, pareho lang siya ng moment of inertia, pero dito second power, dito first power. Okay, ito tinatawag natin to as the first moment, diba, so of an area. So actually marami to, diba? So umaabot hanggang fourth moment, no? Fourth moment of an area naka-raise din sa 4, diba? So depende kasi kung ano yung kailangan nating i-measure, diba? So for the problem. For example, pag center of pressure, diba? So may kinalaman na siya sa moment of inertia, no? Okay? So any questions? Okay? So yan yung tatandaan natin. So pag moment of inertia, so ganito lang. Okay, so mind nyo lang yung R, diba? So yung R natin is the distance kung saan natin sinosolve, diba? So yung distance ng area or ng differential area natin kung saan natin sinosolve yung moment of inertia. So for example, pag sinabing with respect to x-axis, so kailangan kunin natin yung distance niya mula sa x-axis, diba? Pag with respect to y-axis, diba? So then mula sa y-axis, okay? Pag with respect sa origin, so then dapat mula sa origin, no? So let's try an example. Okay? So we have another parabola here. Okay? So yung parabola natin is y squared is equal to 4x. Diba? So as you can see, so this is of the form. Okay? So y squared is equal to 4ax. Diba? So again, na makuha natin dito, the vertex is at 0, 0. Kasi wala nakasubtract sa y and x. Diba? So and pangalawa, so this opens to the right. Diba? Kasi y yung naka-square, so tapos positive yung x. Okay? Okay ba? So then, so kunin natin yung boundary niya. Boundary is the line x is equal to 1. So then at x is equal to 1. So we have y squared is equal to 4 times 1. So which will give us y is equal to plus or minus 2. So which means, this is the point 1, 2. Saka 1, negative 2. Okay? Nakuha ba? So then, pag ginraft natin siya, so ganito yung kalalabasan. No? So makikita natin wala naman tayong limitation tungkol dun sa quadrant, diba? So therefore, buong parabola yung consider natin dito, no? Okay, so meron kasi ganito rin problem tapos ang nakalagay lang first quadrant, no? So ingat kayo dun. Okay? Okay? So let's say this is 1. So this is 1, 2. Negative 1, negative 2. Thus this is 1, 2, no? So therefore, we have the vertex. We have the point 1, 2. Saka 1, negative 2. So this is the line. X is equal to 1. Diba? So then this is the parabola. Okay, so ito yung kinukunan natin ng moment of inertia. Okay, nakuha ba? So tatandaan natin ang hinahanap natin dito ay with respect sa x-axis. No? Pag ang hinahanap natin is with respect sa x-axis or sa y-axis, ang pinakamagandang gamitin is rectangular strip na parallel dun sa hinahanapan natin na axis. For example, dito x-axis is horizontal, so therefore we better use the horizontal strips. Okay? So yung reason, diba, is pag horizontal strip, pag kinonsider natin lahat ng points sa horizontal strip natin, equidistant lang siya from the x-axis. So lahat sila equal sa y-coordinate. Diba? So nung parabola natin. Okay, so pare-pareho sila ng y-coordinate so with the point on the parabola. Okay? So kaya yan yung pinakamagandang gamitin, horizontal strip. Pag with respect sa y-axis, pinakamagandang gamitin ay vertical strip. Pag with respect to the origin, so ang pinakamagandang gamitin ay double integration. No? So kung hindi man double integration, para siyang circular strips. Okay? Nakuha ba? So or parang mga circular arcs, diba? So yung gagamitin nyo doon. Okay? So pero again, 'di ba? So dito sa problem na 'to, ang pinakamagandang gamitin ay horizontal strip, no? Okay? So the thickness, so as you can see, is along the vertical. So kaya ibig sabihin this is dy. So and para sa length naman na 'to, 'di ba? So remember, so the right boundary is this one. That is x is equal to 1. So this is the right boundary. The left boundary naman is the parabola. So again, from this equation, okay? So we can say that this is x is equal to y squared over 4. So this is x is equal to y squared over 4. So this is our left boundary. Diba? Okay, so then, so pag kinuha natin to, so this is simply x right, diba, minus x left. Diba? Okay, so therefore, so let's start with the differential area. Okay, so the differential area is simply equal to, so xr minus xl multiplied by dy. Diba? So yung xr natin, so is given by 1. xl is y squared over 4. So then this quantity dy. No? Okay? Nakuha ba? So the next step is the moment of inertia with respect to the x-axis. Diba? So again, so dito ang titingnan natin is yung r squared dA. Yung r natin being y. So ito yung gagamitin natin r. Kasi yun yung layo from the x-axis. So therefore, this is y squared. Yung dA natin is simply 1 minus y squared over 4 dy. So therefore, solving for the moment of inertia, so this will be the integral of y squared times 1 minus y squared over 4. So this quantity dy, so this is from 0 to, from negative 2 to 2. Diba? Kasi consider natin lahat ng horizontal strip. So from negative 2 to positive 2. So negative 2 to positive 2. Diba? So this is our moment of inertia. Diba? So we have integral, diba? So ng y squared times 1 minus y squared over 4. So this is from negative 2 to positive 2. Okay. So you will get, so 2.133. Diba? So ganyan lang yung moment of inertia. No? Okay? Nakuha ba? So any questions? Okay, so para dito. Okay? Okay? So next. No? So force on a submerged plate, diba? So or yung tinatawag natin na fluid force. Okay? Nakuha ba? So dito basic lang yung idea natin, diba? So we have, let's say ito yung surface natin. So this is the fluid surface. So tapos merong nakalubog dito na plate, diba? Okay? So syempre, diba, yung idea kasi natin dito, diba? So is basically, so imagine nyo ito yung side view ng plate natin. Diba? So this is the side view of the plate. Okay, so then, so meron ditong force, meron siya nararamdaman na force, 'di ba? Doon sa ilalim ng tubig, 'di ba? So which is proportional doon sa tinatawag natin na fluid pressure, 'di ba? And alam natin na yung fluid pressure, palaki siya ng palaki. So habang bumababa o lumalalim tayo doon sa fluid natin. Mas malalim sa fluid, mas malaki yung fluid pressure, mas malaki yung fluid force, 'di ba? So kaya ito, so this is not your average na, kumbaga ina-average lang natin yung force, no? So again, so this is different. So kailangan natin i-consider so yung increasing pressure, so para doon sa total force natin. So kaya gumagamit tayo dito ng integration, no? So again, so ang ginagamit natin dito usually is horizontal strips, no? Okay? So horizontal strip. Bakit horizontal strip? Kasi nga every point dun sa horizontal strip natin is equidistant mula dun sa surface, 'di ba? And we can define this as h. Okay? So kasi pag alam natin yung height, 'di ba? So then we can say that the pressure experienced, 'di ba? So by this differential area, 'di ba? So again, so yung pressure na may experience niya, so will just be given by, so this is omega, so multiplied by height h. Okay? Nako ba? So again, that's the pressure natin, 'di ba? So again, sa position na to, okay, so again, so nung dun sa area natin, 'di ba? So therefore, for this differential area, the differential force experienced, 'di ba? So will be given by pressure multiplied by the differential area. Remember that pressure is force over area. Kaya force natin is pressure times the area. And since yung pressure natin is omega h, so then we can write this omega h dA. Diba? So therefore, yung fluid force natin is the integral over the area. Diba? So ng omega, so times h dA. So this is one equation. Okay? Okay ba? So ano yung omega natin? So omega is yung tinatawag natin na specific weight. Okay? Naka ba? Pag specific weight, so ang ibig sabihin nito, this is weight divided by the volume. Okay? Naka ba? In some books, 'di ba? Ang ginagamit dito na unit na symbol ay rho. Pero sa lecture namin usually omega yung ginagamit namin kasi yung rho is para sa mass density. 'Di ba? Okay? So kaya yung omega yung ginagamit namin for specific weight. Pero sa ibang problem makikita niyo nakalagay is rho. 'Di ba? So pero makikita natin yung unit is weight, 'di ba? Halimbawa ng weight is newton, 'di ba? So naka-newton per cubic meter. So omega 'yun, 'di ba? Pag pounds per cubic foot, omega 'yun. Okay? Okay ba? So ang tatandaan lang natin dito is yung sa water. So kasi kadalasan pag water yung given, hindi siya given. No? So pag water yung nasa problem, hindi given yung omega. Okay? So yung omega natin for water is 9.81. So kilonewton per cubic meter. No? So pag English unit naman, so we use 62.4. So this is pounds per cubic foot. Okay? Pag hindi lang given sa problem yung sa water. Pero pag may given naman sa water, kung ano yung given, so yun yung gamitin nyo. Okay? So yan yung force natin. So now, okay, so omega is constant. Diba? Pag constant yung omega natin, pwede natin siya ilabas ng integration. So therefore, the force will be omega, so integral ng h dA, so over the area. But as you can see, itong term na to, this is the first moment. Diba? So first moment of an area. Okay, so pag first moment of an area, equal lang siya dun sa centroid times the area. Diba? So therefore, pag alam natin yung location ng centroid nung naka-submerged na plate, so kahit hindi tayo mag-integrate. Diba? So this is simply omega h bar times the area. Okay? Okay? So yung dalawa yung tatandaan nyo. Diba? Pag alam nyo yung equation ng area, saka yung location ng centroid, hindi nyo na kailangan mag-integrate. Diba? Familiar, diba? So kasi ganyan din yung ginagawa natin sa solid of revolution. Diba? So kaya again, sobrang laking advantage para sa atin pag memoryado nyo yung equation ng area sa yung location ng centroid for common figures. Diba? So ganun din naman dito sa mga submerged plate. Ang mga common dito ay conic sections, so tapos triangles and rectangles. Okay, nako ba? So pareho nung sa solid of revolution. No? So yun din yung mga common. Okay, nako ba? So any questions para dito? Okay. So we will try some example. Okay. Okay, saglit lang. Ha? Wala ko ng tubig. Okay? So let's start again. No? Okay? So again, so let's try this problem. No? So dito, so we have a rectangular plate. No? So again, so let's say ito yung surface natin. So we have the surface. Okay, so then we have a rectangular plate, 6 meters by 8 meters. Submerged vertically. So since nakalagay dito, submerged vertically, so ibig sabihin, yung 8 meters natin, so dapat siya ay vertical. Diba? Dapat mas mahaba yung vertical sa horizontal. So kaya ganito yung orientation niya. Diba? Submerged vertically, diba? So tapos, find the force on one face if the shorter side is uppermost. So ibig sabihin nasa pinaka-tuktok yung ano natin, nasa pinakataas, diba? So yung ating shorter side, so that's 6 meters and lies in the surface of the liquid. So ay nandito siya sa surface ng fluid natin, diba? So meaning this is 6 meters. Okay, so then this is 8 meters. Okay? So again, so we have two ways to answer this problem. So again, the first way is by using, okay, so the horizontal strip, no? So like this one, okay? So again, sa horizontal strip, so ititreat lang natin yung layo nito from the surface as h. So like so, diba? So then, so yung kanyang thickness, diba? So will be dh. Okay, nakabe? So tapos yung width niya, as you can see, rectangle to. Sa rectangle, constant yung width. So, lagi itong equal sa 6 units. Okay? Nakaba? So, basically, so if we solve for the differential area, so the differential area here is equal to 6 dh. Okay? Nakaba? So, ganyan lang. Diba? So, then solving for the differential force. So, again, this is omega h dh. Diba? Okay? So, therefore, okay, omega h dA, sorry, not dh, okay? So omega h dA, so therefore, so by substituting this will be 6 omega, so h dh, diba? So then solving for the force, that will be 6 omega. Constant yung omega natin kasi water lang to, diba? So this will be integral, so ng h dh, diba? So ano yung limits of integration natin? Mula dito sa pinaka-surface, where h is 0, hanggang sa pinaka-bottom ng plate natin, so where h is equal to 8 meters. So therefore, this will be from 0 to 8. Okay? So then, so substitute omega. So this is kilonewton, diba? So therefore, SI unit yung gagamitin natin. So let's use 9.81. So this is kilonewton per cubic meter, diba? So then multiplied by, so yung integration natin, okay? Pag in-integrate natin yan, so x dx lang, so from 0 to 8, so you will get 32, diba? And this will be meters times meter. So this will be, ito meters din to, diba? So kaya basically cubic meters na to, no? So again, meters to, meters to, meters to. So kaya may cubic meters pa tayo dyan. So cancel yung cubic meters, so kaya matitira sa atin ay kilo newton, diba? So we have 32 times 9.81 times 6, diba? So you will get 1,883.52 kilonewton, diba? Okay, so therefore this is letter B. Okay, so again, that's by integration. Diba? Without integration, so dapat alam niyo yung equation for the area. Rectangle lang naman yan, kaya area is base times height. Yung base ay 6 meter, yung height ay 8 meters. So therefore the area is 48 square meter. Pangalawang kailangan natin is the location of the centroid. Pag rectangle, nasa pinakagitna lang yung centroid. Diba? So kaya ibig sabihin, so yung layo natin mula sa top, mula sa surface, is kalahati ng height. Yung height natin 8 meters, so kalahati niya is 4 meters. Diba? So therefore, so yung h bar na gagamitin natin dito, itong h bar na to, yung h bar natin is layo ng centroid from the surface. So kaya 4 meters na yung gagamitin natin. So h bar is 4 meters. Diba? So then solving, so for the force, so again, we can use omega h bar. So this is 9.81. So this is kilonewton per cubic meter. Diba? So multiplied by h bar. So ang h bar natin dito ay 4 meters. Diba? And yung area natin so is 48 square meters. Cancel square meter, cancel yung meter, cancel yung cubic meter. So therefore, we can have the force. Okay? So 9.81 times 4 times 48. Diba? So we get 1,883. So this is 0.52 kilonewton. So pareho lang ilalabas, diba? Without integration man siya or with integration, diba? Okay? So any questions para dito? Okay. So let's try another example, diba? So problem number 13. So this time we have a cylindrical tank, diba? So ito yung sinasabi ko sa inyo kanina, diba? Minsan, diba? So raw yung ginagamit sa mga libro, diba? Even though makikita natin yung unit is pounds per cubic feet, which is technically the weight divided by the volume, diba? So ibig sabihin itong given na to, this is already the specific weight. Okay? Nakuha ba? So hindi siya density. Diba? So kaya ingat kayo dyan sa mga problem natin. So pag raw yung given, so or omega. No? Okay? Nakuha ba? So ang tignan nyo dyan is yung unit kung available. Diba? Pag yung unit is weight over the volume, ibig sabihin specific weight yung given. Diba? So pag naman ang nakalagay is mass per unit volume, so ibig sabihin that's the mass density. Diba? So kaya dito, papalitan ko na itong puno na to, so papalitan ko na siya ng omega. Okay? Nakuha ba? So again, so para hindi tayo malito doon sa equation natin. Okay? So then dito, meron kang cylindrical tank, it's lying on its side. So ibig sabihin nakaganito yung cylinder natin dyan. Okay? So kaya half full siya, so ibig sabihin may laman tong kalahati. Okay? So ibig sabihin hanggang kalahati ng face, ng base natin, hanggang kalahati ng base natin, di ba, is meron is nakasubmerged dun sa oil. Okay? Nakuha ba? So ibig sabihin yung force natin is nararamdaman lang dun sa lower half ng circular base natin. Okay? Nakuha ba? Kaya pag i-drawing natin to, okay? So we can have a circular base, di ba? Tapos nakalagay naman dyan, so this is half full. So ibig sabihin, so dun lang tayo sa lower half. Okay? So ito lang yung nakasubmerged dun sa fluid natin. Or in this case, yung fluid natin is oil. So ibig sabihin, so yan lang yung i-consider natin. Okay? Okay ba? So then, find the force exerted by the oil on one end of the tank. Diba? So again, so two ways to answer this problem. So ang una nating alam dito is that the diameter is 8 feet. So meaning the radius is 4 feet. No? Kalahati ng diameter, kalahati ng 8 is 4. So kaya 4 feet yan. Diba? Tapos nakasubmerge. Diba? Yung kalahati, yung semicircle lang. Okay? So let's consider, diba? So yung horizontal strip natin. So let's say we have this one. Okay, so this is our horizontal strip. Okay, so let's consider this horizontal strip. So una, yung layo natin from the surface. So again, so lagi natin itong dinedefine as h. So if we use a horizontal strip, diba? Yung thickness ng strip natin, diba? So s dh, diba? Kasi yung vertical distance natin ay h, so therefore yung change niya is dh, diba? And as for the width natin dito, so itong width na to, okay? So ang gagawin natin dyan is, hahatiin natin to sa dalawang parts, okay? Nakuha ba? So then doon sa dalawang parts na yan, so tawagin natin to for example as x, tawagin natin to as x, diba? So kaya makikita natin, diba? So na yung total width natin so will be given by 2x, okay? Nakuha ba? And remember that the distance from the center, papunta dito sa isang point natin doon sa gilid, so this is just equal to the radius. So kaya dapat pareho lang siyang 4 feet. Diba? And again, mula dito hanggang dito, diba? So we know this length to be equal to h. Diba? So therefore, so we will form here a right triangle. Diba? So makakabuo kayo ng right triangle dito. Okay, so then we can use Pythagorean theorem. Diba? So by Pythagorean theorem, diba? So we know that, okay? So we have h squared plus x squared. So this is equal to, so we have 4 squared. Okay? Nakuha ba? Okay, so or, okay? So we can write yung h natin. Diba? So as square root of, so 4 squared is 16, so minus x squared. Okay? Nakuha ba? So meron na tayong h. Diba? So dun sa equation. Okay? So as a function of x. Diba? So now let's solve for, or baliktad ba dapat? Sige, baliktad rin natin. No? Okay? So mukhang x yung kailangan ko palang palitan. So therefore, x will be square root of 16 minus h squared. No? So then solving for the differential area, so again, we know the differential area to be 2x multiplied by dh. Diba? So kaya this will be 2 square root of 16 minus h squared dh. Okay? So we have the differential area. So for the differential force, that is simply omega h dh dA. Diba? So then this will be omega. So then times 2 times h. Okay? So we have omega h, no? So multiplied by 2, square root of 16 minus h squared dh. Diba? So then, okay, so to solve the force, we can factor out the constant, that's 2 omega. So then this will be integral, so ng h square root of 16 minus h squared dh, diba? So yung h natin, so we'll start from h is equal to 0, yung pinaka-surface, hanggang sa bottommost part, diba? That's h is equal to the radius, that's 4 feet, diba? So kaya from 0 to 4. Okay? So ano yung omega natin? Omega is 50 or 75. So omega natin ay 75. Okay? So this is pounds per cubic feet, diba? So then yung mas-solve natin dito, remember yung 2x natin dito, so itong 2x na to, saka itong dh na to, parehong feet to. Kasi they are measure of distance. And feet yung ginamit sa problem, so therefore this is in feet. So meaning this is square feet, this is cubic feet, diba? So kaya lalabas sa integral natin will be in cubic feet, diba? So 2 square root of 16 minus h squared, okay? So then, okay, so then dh, diba? So then this will be from 0 to 4. Okay? Okay? So, hinihintay natin yung lalabas sa integral na to. So, I guess medyo matagal siya since may square root. No? Okay? So, while we wait, diba? So, let's solve for the, let's use the other solution. So, I guess isang solution natin, kailangan natin ng area, diba? So, of the semicircle. Diba? So, again, so the area of the semicircle is kalahati ng area ng circle. So, 1/2 pi r squared. So, that's 1/2 pi. So, ang radius dito ay 4 feet. So this quantity squared, so you will get 8 pi. So this will be in square feet. No. Okay, so this will be our area. Okay, nakuha ba? So now, okay, so lumabas na 64 over 3. Okay, so this is 64 over 3. So again, so this will be in cubic feet. No? So kaya magka-cancel to. Okay. Then we have 2 times 75, so times 64 over 3. Okay? So we have 3,200. So this will be in pounds. Okay? Okay ba? So any questions? Para dito? So we have letter B. Okay? So again, so for another solution natin, so this is yung area. Diba? So then ang pangalawang kailangan natin is the location of the centroid. So yung tatandaan natin pagdating sa isang semicircle, so let's say we are given the semicircle. So yung centroid natin, diba, is syempre nasa axis of symmetry. So pag hinati natin ito sa dalawa, so somewhere dyan. Tapos, okay, so nandito siya. Such that yung layo natin, so mula dun sa base, so is given by 4 times the radius divided by 3 pi. Diba? So kaya dito sa figure natin, so pwede nating sabihin na yung centroid natin is nandun sa gitna, somewhere dito, di ba? Tapos yung layo niya from the base, so basically ito na yung h bar natin, di ba? So this is 4r over 3 pi, di ba? So kaya pag sinolve natin to, diba? So we have h bar, so this is equal to, so we have 4r over 3 pi. Okay, nakuha ba? So again, radius natin ay 4 feet. So again, 4 feet. So this is divided by 3 pi. Okay? So pag sinolve natin to, so you will get, so 4 times 4, so divided by 3 pi. Okay? So then you will get, so 1.698. So gawin ko na lang itong 16 over 3 pi. So then this will be in feet. Diba? So then solving for the force, so again that is given by omega, h bar times a. So this is 75. So this is pounds per cubic feet, no? So then multiplied by 16 over 3 pi feet, diba? So then multiplied by, so area, so is 8 pi square feet, no? So kaya cancel yung cubic feet, cancel yung pi. So then, solving this, so 75 times 16 over 3 times 8. Diba? So you will also get 3,200 pounds. Okay? So any questions? Diba? So para dito. Okay. So again, so gaya ng sabi ko sa inyo kanina. So again, omega, so is specific weight. Yung rho is mass density. Diba? Pero gaya sabi ko kanina, so sa ibang libro kasi, yung rho, diba? Especially for English unit, nagiging mass dense, nagiging pounds. Diba? So yung pounds kasi is a unit of weight. Diba? So kaya it's better for us pag ang gamitin natin is omega. No? Kasi yung pounds is a unit of force. Diba? So not a unit of mass. Ang mass natin sa English unit is slugs. Okay? Nakaba? So then, so kopyahin nyo muna. No? Sabit lang. Okay? Sorry about that, no? So again, so yan yung fluid force natin sa solution. Okay? So kaya nung ginawa natin doon sa dalawang problems, so again, there's two solutions. Diba? So na pwede nyo gawin. So with integration or without integration. So kahit ano naman gamitin nyo dyan, diba? So pareho lang naman madali silang gamitin. So basta naiintindihan nyo yung concept. No? Okay? So kasi yung integration, diba? So at least wala kayong kailangan memoryahin. Diba? So yung solution natin, so lies, naglalay lang siya dun sa figure natin. Diba? So basically, area lang siya ng rectangle. Diba? So base times height. So tapos, concept lang siya ng force. Diba? So which is omega HdA. So we just follow that. Diba? So then, so kahit anong pa man ang ibigay sa atin na figure, we can solve. Diba? Okay? So pero yung sa without integration naman natin, so again, this is limited only to figures kung saan memoryado natin yung direct formula sa area saka direct formula sa h-bar. Okay? Nakuha ba? So actually may mga direct formula din tong fluid force. Depende sa shape na kino-consider natin. No? So pero kayo na yung bahala kung gusto nyo aralin yung part na yan. So you can derive naman, diba? So using the direct formula. For example dito, so ipasok nyo to dun sa area, diba? Tapos ipasok nyo to dun sa h-bar. So then then we have the omega, diba? So which is just a constant, okay? So then tignan nyo kung ano yung magiging form ng equation, diba? So pero syempre limited lang siya dun sa mga figure, so with the diameter at the surface, tapos semicircular shape, diba? So pero again, so for different shapes, pwede nyo i-derive yung iba't ibang formula na pwedeng gamitin, diba? So pero kayo na yung bahala kung gusto nyo gawin, diba? Okay? So ang importante, so alam nyo pa paano yung paraan ng pag-solve, diba? Okay? So any questions? Diba? So again, so yung pinakamagandang gawin pa rin dito is to memorize the area and the location of the centroid for different figures, especially conic sections, kasi sila yung mga madadalas lumabas, saka yung mga part nila. For example, mga semi, saka mga quarter. Diba? So kasi lumalabas din yan sa board exam. So then we have triangles, So then we have rectangles, diba? Yun lang naman yung mga madadalas lumabas sa board exam. So pag hindi ganun yung lumabas sa board, so na shape, so then use integration. Diba? So ay maganda na alam nyo pa rin pareho. Okay? So ayan. So nung nag-review ako sa board dati, sa nung nagbo-board exam ako, pag naka-encounter ako ng mga ganitong problem, so tinatry ko na lang parehong solution. Diba? So para at least sigurado. Kasi pag pareho yung lumabas sa sagot, ibig sabihin tama talaga yung solution natin. No? Okay? So let's proceed to the next topic. Diba? So which is work done by a spring. Diba? Yung tatandaan nyo lang pagdating sa work done, diba? So yung work done natin is basically, diba? So force, diba? So dot product with the displacement, okay? So it's the displacement S. Okay? So kaya in terms of magnitude, this is the magnitude of the force times the displacement, so times cosine of theta, diba? So yung theta is the angle between the force and the displacement. So let's say ito yung displacement natin. Tapos yung force natin is directed in this direction. Diba? So rin ito yung angle theta natin. Okay? Okay ba? So pagdating sa isang spring, diba? So you can imagine na for example, okay? So again, so let's say ito yung spring natin. Okay? So tapos let's say meron ka ditong okay? So let's say meron ka ditong object. Okay? Okay ba? So then, so yung object, so let's say yung object natin gumagalaw, diba? So we have a displacement S here. Okay? Okay? So then, so we can imagine, so na habang gumagalaw dito yung object natin, so then the force exerted by the spring, diba? So can be in this direction. Pwede siyang dito sa direction na to. Diba? So which is anti-parallel with the displacement. So pwede rin naman siyang in this direction. Diba? So kasi pag yung spring natin is initially compressed, diba? So then ibig sabihin itutulak niya yung itong object natin, diba? So pag naman siya initially expanded, diba? So then so habang lumalayo to, diba? So then hinihila niya naman pabalik yung object natin. So therefore, so yung force natin is either 0 degree or 180 degree yung angle natin for the displacement, diba? So pero kadalasan ang kino-consider natin dito is yung positive component, diba? So which means so we are considering this force here, diba? Okay? So kino-consider na lang natin siya depende dun sa position ng object natin. So with respect to the spring. So pag pinasok natin dun sa equation ng work, diba? So basically yung work natin, diba? So will be given by, okay? So the differential work, diba? So will be given by, so this is so this will be given by F, diba? So then this will be dx or ds. Okay? Nakuha ba? So again, so this will be our differential work, no? So if we consider an infinitesimal increase, diba? So or yung infinitesimal motion, so nung object natin for example in that direction or in this direction, diba? So remember na yung force natin, so for a given spring is given by K multiplied by X minus X sub 0, diba? So in this case, since S yung ginamit ko, diba? So then this will be S minus S sub 0. Okay? Diba? So palitan na lang natin siguro ng variable, diba? Since this is in the horizontal direction, so gawin natin tong X. Diba? So then this will be X, so then this will be X sub 0. Okay? So then this will become dx, no? So para pareho ng mga nasa libro. Okay? Nakuha ba? So again, so the idea is pag nag-move to ng infinitesimal amount, diba? So let's say, so this moved, diba? So by an amount dx. Okay? Nakuha ba? So then this is the amount of force, diba? So na i-exert ng spring natin, diba? So kaya this will be given by, so we have a constant K. So ito yung spring constant natin. So guys, ito dapat na pag-aralan nyo ito nung sa mechanics nyo, diba? Most likely naman, so nag-mechanics kayo dyan sa school nyo, diba? So again, so this is K, so times X minus X sub 0. Yung X sub 0 natin dito is the original length, okay? So again, this is the original length, okay? Nakabasa nung spring natin, okay? Nakabasa yung X naman is yung final length, diba? So of the spring. Okay, so kaya makikita natin that this is negative, diba? So kung naka-compress yung spring natin, tapos siya naman ay positive pag naka-expand yung spring natin. Okay, naka ba? So itong x minus x sub 0 natin, di ba? So this is less than the original length pag naka-compress, greater than the original length pag naka-expand. Di ba? So kaya yun yung lalabas, di ba? So then this is multiplied by dx. So yun yung magiging differential work. So kapag in-add up natin yung mga differential work nito, di ba? So again, so during its process ng pag-move, di ba? So you will get that the work done, so will just be equal to, so constant lang yan. So then we have integral, so ng x minus x sub 0 dx, diba? So again, so over its entire motion. So for example, from position 1 papunta sa position 2, diba? So pag ginawa natin yan, so this will just be k multiplied by, so x minus x sub 0, so by power rule, squared divided by 2, diba? Tapos ang derivative naman ng nasa loob is just 1. So kaya hindi lang siya lalabas dun sa equation natin. So this is evaluated from x1 to x2. So therefore, the work done for a spring is 1/2 k multiplied by, so this is x2 minus x0 quantity squared minus, so this is x1, okay, minus x0, so this is quantity squared, diba? So or pwede mo siyang isipin as 1/2 k multiplied by, so this is delta x2 squared minus delta x1 squared, no? So again, ang tinitingnan natin dito is yung change in length, diba? So ng spring natin, so from its original length, diba? So yung hindi naka-compress, hindi naka-elongate, diba? So kaya pag work done by a spring, direct formula lang yung gagamitin natin, diba? So although yung concept na ginamit natin dito is also integration, okay? So try natin this example. So if a force of 400 newtons so stretches 3 meters by 0.5 meter. So remember, delta x na to. Diba? So ang equation natin for the force, diba? So again, this is given by k multiplied by x minus x sub 0. So again, so ito ay delta x na mismo. Diba? So which means, so yung delta x natin ay yung spring constant natin. Diba? So it's just equal to yung force na in-exert natin, so para sa elongation na delta x. So this is 400 Newton divided by 0.5 meters. Okay? So you will get that this is 800 Newton per meter. Diba? So then find the work done in stretching it from 3 meters to 5 meters. Diba? So again, direct formula natin for the work done. So it's 1/2 k multiplied by, so we have x2 minus x sub 0 squared minus, so we have x1 minus x sub 0 squared. So again, direct formula. So we have 1/2 times 800 Newton per meter multiplied by, so again, ang x2 natin dito ay 5 meters minus original length 3 meter squared minus, so we have 3 meters, original length is 3 meters squared. So then this is 0. So kaya lalabas dito ay equal lang sa, so we have 3,200. So we have 1,600. So this is in square meters. Diba? So cancel yung meter. So Newton meter or joules. Convert natin sa kilojoule. So we have 1 kilojoule for every 1,000 or 10 to the 3 joules. Diba? So kaya tandaan nyo lang dito yung direct formula natin. So we have 1.6 kilojoule. Okay? Nakaba? So actually lumalabas din sa ESAS. So yung ganitong uri ng problem. Okay? So siguro sa ibang courses is yung equivalent ng engineering sciences. Diba? So lumalabas yung ganyang uri ng problem. So I think GIAS ata siya doon sa ECE. No? Okay? So any questions? No? Okay? So tandaan nyo na equation na to. So pag work done by a spring, so ito naman pag force. Diba? So yung force ng spring natin. Okay? So next is the work done by a pump. No? Sa work done by a pump naman, so meron din to kinalaman sa pressure. Diba? Okay? So kasi yung work done natin, diba? So gaya ng kanina, diba? So na ginamit natin. So work done is just force. Diba? So then multiplied by the displacement. Okay? Okay ba? So again, so this is F dot S. Diba? So equivalent sa F, so times S, cosine of theta. Diba? So pero pagdating naman sa pagpapump ng water, so imagine natin, so we have, let's say, a cylinder. Okay? So let's say yung water. So yung water, diba, is pinapump natin, for example, pataas, diba? So kaya yung force na ina-exert natin dito ay pataas, diba? So tapos yung displacement ng water natin is also pataas. So therefore, the angle, diba, so between them is 0. So kaya cosine 0 din yung lalabas dito. So kaya this will just be equal to 1. Diba? So again, para sa isang pump, diba? Kaya force times displacement lang yung lalabas. Okay? Okay ba? So saan ba equal yung force natin dito? So again, yung force natin dito is just equivalent to pressure, diba? So multiplied by the area. Okay? So yung area natin dyan is yung cross-sectional area, diba? So nang pinapump natin pataas. Okay? Okay ba? So then this is multiplied by, so yung S naman natin dito is simply dH. Diba? So again, so let's say we have the thickness here, dH, diba? So para dun sa volume, diba? So na gusto natin ipump pataas, diba? So itong volume na to, so for example, we have this volume here. Okay? So itong differential volume na to, ipapump natin pataas. So that will be dH, diba? Pero since part lang siya ng volume na pinapump natin, so dW pa lang yan, diba? And remember na yung ADH na to, so this is cross-sectional area times dH, that is just the differential volume ng pinapump natin, diba? So meaning, this is pressure, so multiplied by dV. So again, alam naman natin yung pressure is omega H, diba? So omega H dV, so then this is our dW. So therefore, the work done is just the integral over the volume, so ng omega H dV. So makikita natin pareho lang siya sa fluid force. Ang pinagkaiba nga lang niya is volume yung ginagamit natin instead of the area. Diba? So then if omega is constant, diba? So then pwede natin siyang ilabas ng equation. So then this will be omega, so then integral ng H dV. So then this will be given by omega, so H bar times the volume V. No? So this is our direct formula. So although dun sa problem na example natin, itong integration lang yung gagamitin natin. Okay? Wala kasi tayong direct formula for the centroid of a frustum. So although pwede natin siyang isolve considering a cone minus another cone, diba? So pero medyo hahaba yung solution natin, diba? So kaya doon na lang tayo sa integration solution. Okay? Pero pag alam niyo yung direct formula for the centroid of volume, saka yung volume, diba? So ng given na solid, so pwede niyo gamitin, diba? So itong equation na to para wala lang integration. Okay? So pero again, so hindi niyo naman alam yung formulas, diba? So then, so pwede natin gamitin yung integration. So actually dito integration yung usual kong ginagamit. Diba? So nung nagre-review ako, so kasi parang hindi worth it kasi yung memoryahin yung centroid ng volumes, no? So kasi bihira naman siya lumabas sa board exam. So at least REE, no? Bihira ako makakita ng problem na three-dimensional, diba? So pagdating sa board examination, especially pagdating sa integration. Okay? Kung meron man lumalabas sa board exam, usually nasa less than 2% or less than 3%, no? Okay? So kaya mababa lang yung chance, okay? So kaya mas pinipili ko na yung way na konti lang yung kailangan kong memoryahin, so pero kaya ko pa rin i-solve yung problem in case na kailanganin, diba? Okay? So yan. Okay, so let's try integration, diba? So for the next problem, okay? So okay, so yung nakalagay dito kasi na shape natin dito sa frustum. No? Frustum of a right circular cone. Okay, okay ba? So yun yung reason kaya hindi na natin gagamitin dito yung without integration na solution. So unlike kasi dun sa fluid force natin kanina, isang direct formula lang meron na tayo. Sa frustum kasi wala siyang direct formula. Although pwede kayo mag-derive ng sarili niyong formula, so pero I doubt magiging simple lang yung equation. No? So kasi kung simple lang yung equation ng centroid, ng frustum, ng right circular cone, diba? So then, madali sana natin makikita yun sa net. No? Okay? Okay? So pero dati sinerch ko na yan, so pero walang lumalabas. Diba? So ibig sabihin, kung meron mang direct formula, so hindi siya ganun kaganda yung itsura. No? Possibly may mga square root na makikita dun sa equation. So kaya hindi siya worth it na memoryahin. Diba? So although again, gaya na sabi ko kanina, pwede natin siyang isolve. Kasi frustum ng cone is just a cone minus a smaller cone. Diba? Okay? So pero anyway, diba? So let's use the integration formula. So first, diba? So we have a frustum shape na container, diba? Or tank in this problem. So again, pag sinabi natin frustum, so imagine nyo lang meron kayong circular cone, tapos tinanggal nyo yung top na part. such that yung base na, yung dalawang base ng frustum natin are parallel to each other. Diba? So basically, so let's say ito yung lateral